So we're picking up where we left off yesterday with creating and canceling a common factor. So yesterday we learned how to cancel a common factor out by either factoring or coming up with some solution. Whenever I look at this one, there's a problem with that because there is no common factor. So first I need to see if my limit does exist. So if I'm checking to see if my limit exists in the first place, then I need to plug a 0 in. So I'm going to try to plug a 0 in first and see if that's possible. Up here that gives me 0 squared, which is 0, plus 100, which is square root of 100, that's 10. 10 minus 10 is 0. But on the bottom, if I plug a 0 in, I'm dividing by 0. I can't divide by 0. So I know that that creates a problem for me. So I can't solve this one by just plugging in. And there's no common factor when I just look at it. So basically, I need to create a common factor. When I look at this top here, this square root is going to throw me off every time. Now in pre-calc we learned about rationalizing the denominator, which would be getting rid of this root. So I'm going to try to take that same approach to see if I can get rid of the square root, if possible. And if I can, then it's going to simplify the problem for me. So the only way that I could get rid of this square root in the top is to multiply this top by its conjugate. So if I can't, if I'm looking at the problem, as soon as I see this square root and I try to plug a 0 in and it doesn't work, I'm going to come to this conclusion where I'm going to be trying to create and cancel the common factor. So I'm going to multiply by the top by its conjugate, and whatever I do to the top, I have to do to the bottom. So if I multiply the top by its conjugate, it means that I leave what's under the root is exactly the same. X squared plus 100. And then I change the sign outside of the root. So that would then be plus 10. And whatever I do to the top now, I have to do to the bottom. So I have to multiply the bottom by the same exact thing. Now when I look at multiplying this top out, I have to go back to like Algebra 2 where we multiply binomials. This is my first term times my first term. If I have the square root of something times itself, it cancels the square root out and I'm left with whatever was under the root. So this is still the limit as x approaches 0 of, and then x square root of x squared plus 100 times the square root of x squared plus 100 leaves me with just x squared plus 100. I canceled the root out. Then I have to continue to distribute this to each of the terms. So I have to do square root of x squared plus 100 times 10, which means the 10 comes out in front of the root. Then I have to distribute the negative 10. This would be minus 10 times the square root of x squared plus 100. And then negative 10 times 10, which gives us minus 100. So my top is done. On the bottom now, I'm just going to start by leaving my x squared times all this. Now on the top, I have some things that cancel out. I have plus 10 times the square root of x squared plus 100 minus 10 times the square root of x squared plus 100. So those cancel each other out. 10 minus 10 is 0. Then I also have 100 minus 100. So that cancels each other out as well. All I'm left with on the top is x squared. So it's the limit as x approaches 0 of x squared over x squared times the square root of x squared plus 100 plus 10. Now I should see what I can do here. Because I have an x squared on the top and an x squared on the bottom, that's a factor of this. So because I'm multiplying, I'm not adding or subtracting, I can cancel my x squareds out. That leaves me with the limit as x approaches 0 of 1 over the square root of x squared plus 100 plus 10. Now if I look at this, there's nothing else I can cancel. So I'm going to try to plug my 0 back in. So if I plug my 0 back in, there's nothing to plug into in the top, so that stays 1. Here in the bottom, 0 squared is 0, plus 100 is 100. Square root of 100 is 10, and 10 plus 10 is 20. So my final answer would be 1 over 20. Questions? Okay, so the question is, how did I come up with this? What to multiply by? I know that I need to cancel this out. So I need to get rid of my root in order to do anything with this problem. And the only way that I can do that is to multiply by the conjugate. The conjugate being leaving the first part exactly the same, because really this is two terms. That's one term, and this is the second term. So I leave the first term exactly the same that I'm multiplying by. And then on the second term, all I do is switch the sign. If it's a negative, I make it positive. And that will cancel my roots out every time. So that's why I'm always going to search for that conjugate as soon as I see the square root in the problem and determine that I can't plug the 0 in. And then I'm going to automatically look for the conjugate, just so I can cancel that square root out on the top. Do you want to do another one? All right, I agree. Let's try this one. So first I want you to determine what you're going to multiply this by. Well, first see if you can plug the x in for what x is approaching. And if you can't, tell me what you would multiply this by. So here if I plug the negative 1 in to the denominator, negative 1 plus 1 equals 0. So I know I can't do that. It's an easy, quick test. If it works, then it makes it nice. But since it doesn't work, we have to multiply by the conjugate. Square root of x squared plus 8 plus 3. Whatever I do to the top, I have to do to the bottom. Now, in general, I won't multiply this bottom out until I absolutely have to. Since our goal is to get rid of this top, now what would I get when I start to FOIL this? Square root times square root. Multiplying that out just gets rid of my square root. This stays as x squared plus 8. Then if I multiply what's on the outside, or distribute this from the first term to the last term. That gives me plus 3 times the square root of x squared plus 8. Once that's done, I have to distribute this negative 3 to both of these terms back here. So this becomes minus 3 times the square root of x squared plus 8. Then we go to our last term. Negative 3 times 3 gives me negative 9. Now in the bottom, I'm not going to multiply that out. I'm going to leave it as x plus 1 times the square root of x squared plus 8 plus 3. What happens on the top now? Good. My middle terms will cancel out. So this 3 and this negative 3 cancel. If that doesn't happen, then you didn't multiply by the conjugate correctly. So that should always happen every time. Okay, is there anything else I can combine on the top? Here I have a plus 8 and a minus 9. So I can combine those two. X squared minus 1. Leave the bottom the same. Okay. Do you see anything I can do with either the top or the bottom now? There is both an x squared, but this one's under a square root, and it's being added to something. So I can't cancel that out. Also, this one's added, or has negative 1 subtracted from it. Could I factor the top out? As soon as I look at the top, it's x squared minus 1, which means that's a difference of 2 squares. X squared minus 1 is the same as x plus 1 times x minus 1. Everyone see where that came from? Just think about foiling this. X times x is x squared. X times negative 1 is negative 1x. 1 times x is positive 1x. 1 times negative 1 is negative 1. Negative 1x plus 1x cancel. I would have x squared minus 1. Got to remember those factors, how you factor things out. Oops. Okay, now when I look at this, I have a factor on top, x plus 1 times x minus 1, and x plus 1 times all of this. Since those are multiples, I can cancel them out. On the top, I'm left with x minus 1. On the bottom, I'm left with square root of x squared plus 8 plus 3. There's nothing I can do to relate these two now. So now I'm going to try to plug in my negative 1. Negative 1 minus 1 on top On the bottom, this is the square root of negative 1 squared plus 8 plus 3. Negative 1 minus 1 is what? Negative 2. Negative 1 squared positive 1. Anytime we do a negative times a negative, it's a positive. So it's positive 1 plus 8, which gives us 9. Square root of 9 plus 3. What's the square root of 9? 3. So we have 3 plus 3 in the denominator, so it's negative 2 6, which is equal to negative 1/3. This is a very long process. But as long as you're multiplying by the conjugate and then looking for a way to factor out, you should be fine on each one of these. And I didn't put any of those. What's that? No, this is it. No shortcuts. All right. Well, on your homework tonight, there aren't any of those questions. Did anybody look at their homework for tonight yet? On 19 through 24, whenever you're doing those ones, all of these ones require you to be able to factor. So let's say we look at number 19. I have the limit, it's x approaches 5 of x minus 5 over x squared minus 25. If I plug a 5 in, it's going to give me a 0 on top and a 0 on the bottom. So you can't just plug it in, which means you now have to find something that cancels out. As soon as I see an x squared in the bottom, I'm going to think I can either use the quadratic formula to find what those are, what my zeros are, or I can factor it. I will say that for probably all of these, there's a way to factor the bottom out. Top stays the same. What multiplies to give me x squared? X and x. What multiplies to give me negative 25? 5 and negative 5. So it has to multiply to give me negative 25. And if we think about our, when we're factoring it out, there's got to be a middle term x. So if I'm doing 5 and negative 5, it has to multiply to give me negative 25. And in this case, there's no x in the middle, so it has to add to give me 0. 5 plus negative 5 is 0. So I know I have my two factors, x plus 5 and x minus 5. Now what can I do? Cancel the x minus 5s out. I have the limit as x approaches 5 of 1 over x plus 5. Now can I plug 5 in? Right. Good. And that's my limit. For all of these, you won't be able to plug them in, but for the first 6, you are able to plug them in. If you can plug it in, you just solve it like normal. Like if I look back at this number 1, I do 2 times -7, that's -14. -14 plus 5 is -9. That's my answer. But for all these ones where there's a denominator, I can almost guarantee you won't be able to plug them in. Like if just looking through them quick. -3 squared is 9. 9 minus 12 is -3. -3 plus 3 is 0. So I would end up with a 0 in the denominator, so I can't do it. We want to do one more of these. Which one you want to do? Okay, we'll do 24 because that one has factoring all over the place. So does 23 actually. Okay, so if we do the limit as t approaches -1, first thing I'm going to do is try to plug -1. -1 squared is 1. 1 minus 1, I'm sorry, 1 plus 1, because it's minus a negative. And then -2. 1 plus 1 is 2. -2 is 0. So I can't do that. So now I need to look at factoring. (24). So on the top, what will multiply to give me t squared? T and t. What multiplies to give me +2 and adds to give me +3? Two and 1. Those are both positive, so it's t plus 2, t plus 1. On the bottom, what multiplies to get me t squared? T and t. What multiplies to give me -2 and adds to give me -1? -2, +1. What can I do now? Cancel out t plus 1. That leaves me with the limit as t approaches -1 of t plus 2 over t minus 2. Can I do anything with these? I can't, so I plug a -1 in for t. -1 plus 2 is 1. -1 minus 2 is -3. That's our answer.